Hello, this is Greg Deckler, and welcome to Microsoft Hates Greg. Okay, so a couple videos ago, I took a look at the index, offset, and window functions, and kind of came to the conclusion that they were kind of meh. I didn't really see them, unlike a lot of my peers that wrote very glowingly of these functions or did in videos, that sort of thing. Uh, Many of my peers, not all of them. Um, I really didn't find them that exciting. They really don't allow us to do anything that we couldn't already do before. I take exception that that in the blog post announcing them, like, oh, it's much easier now to do it this way versus the kind of the traditional way that people have done it with using top N or using path and path item and things like that. Um, so I don't know. I still feel that way, and I've been doing more experimentation with them, and I found kind of even more things that are just wrong about these functions or things that will get you into trouble, easy ways to break them or where they become useless. Um, and so all of that doesn't speak as easy to me. What's easy is to get wrong results or to get in yourself into a situation where you can't use these functions at all. And I'll show you some of that in today's video. So we're going to focus in. I didn't do much more experimentation with window, but I did with some index and offset. So that's what we're going to cover today. And you know me, I'm always experimenting with things and trying to break stuff and trying to do weird, wacky things like you know, do recursion in DAX and things like that with the Holt Winters algorithms, whatever. All right, so let's get into it. I have this even more offset, and I'll update the PBX out there in the GitHub repository. This offset no offset PBX that's in the Microsoft Hates Greg GitHub repository. Still working with the same data set from the last time that we covered these functions. But what I did was I created a dim customer 2 table. And the dim customer 2 table, what I did was I wanted to experiment with index. I had the crazy idea. Well, hey, index works, but what happens if you have duplicate values? What happens then? So I figured I'd create an experiment and find out. So basically, what I do is I grab. Then we from the last experiment, Adriana Garcia was the oldest person in the customer database with the last name Garcia. So her customer key is 23500. So I grab that row and then I union up a select columns where I'm just selecting out the columns I need, which are customer key, birth date, last name, full name. And then I invented a new row, and gave it the same birth date and the same last name, and then gave it a new customer key that's unique, and then a full name of AAA Garcia, just a made up name. So, but this one has the same last name and the same birth date as Adriana Garcia. Okay, so let's see what happens when we have a situation like that. So here is the same implementation of that I used in the last one. Obviously, we're using dim customer 2 versus dim customer, but this is the same construct they used in the blog article. And as you can see, you get lots of errors. In terms, in fact, it's all errors. And it says index, this relation parameter may have duplicate rows. May have. This is not allowed. Okay, relation parameter. Okay, which one is that one, right? So if we go and we look on here, we read the documentation, the relation parameter is the second parameter, which is a table expression from which the output is returned. Not sure why it's the relation parameter. So it seems like an odd name, but I'm assuming there's some kind of reasonable reason for it. Not that I would know what that is. So first thing of course, then I thought, okay, well, if it's an optional parameter, right? It says it's optional. Well, and there's my Holt Winter stuff. It says that it's an optional parameter right here. So what if we just took it out? It says, okay, the order and partition by must come from a single table. Defaults to all selected of all columns by order by and sort by. So, what happens if we just take it out of there? Maybe we can remove the problem. So I did that here. I just took out the reference to the table and all errors again. But this time, function select columns expects a column name as argument 2. All right, so okay, maybe, all right, so So can't make this stuff up. And maybe this, so let's do F name. Let's do that and see what happens. And yeah, that is definitely not correct. Whatever it's doing there. Um, so is it all selected? So one, it's bizarre that if we have that second parameter in there for our index, that it yells about not having a column name, whereas before it's just fine. But then when we take that out and then do this, we just basically we're just returning the same row. Because I guess probably that all selected is selecting that row. So you know it doesn't work regardless. Bizarre stuff. Weird, bad error messages. Um, I guess you can't say incorrect documentation. It actually is optional. Why it then causes problems with select columns, uh, who knows? Um, yeah, it's pretty interesting in terms of the difference. All we did was take out the table name. And then, with this table name in here, then it's okay to not have our second parameter, even though the DAX, says it's wrong, but it actually works. Um, it actually executes. But if we don't have that table name in there, then we need the second parameter for our select columns. Just weird, wacky, bizarre behavior, man. Okay, versus if we do it the way this way, which is the way I presented in the last video, where we don't, need um, we don't need it, right? We don't need index. We can just do it the old-fashioned way of just doing a double lookup. We're doing, look up the birth date, the min birth date, look up the customer date. In this case, if you can see it returns AAA Garcia. Now I can actually, you know, work with this. If I want to return, there is a duplicate value there. So if I return max X instead, you will see that it changes to Adriana Garcia. And that is because Adriana comes after AAA. And so therefore AAA Garcia is the min and Adriana Garcia is the max. The point though being is that at least, we don't get basically a stoppage where we can't do anything, right? This index relation parameter having duplicate values basically invalidates and makes index useless. Okay, I can't get around that error. This is a nice black box. It returns an error. I can't do anything to get around it if I have duplicate values in there. So therefore, it is useless in situations where you have duplicates. Versus if you do it this way, right? You can get around that because you actually can return a table that you can then do something with, like get the max X of it, or get the min X of it, or do whatever you really want to with it. You could concatenate it up and then grab a particular value out. All of those kind of fun stuff become possible. But the minute that the DAX function returns, an error where it's basically stopping, then there's nothing you can do. Okay, and then the same thing is true with sorry, there was a bug that flew by. Same thing is true with the other more generalized version of the no index way of doing things, where we do a concatenate X, generate series. We've used the path item, and all of that fun stuff. And again, it works the same way, where I'm getting, the result. In this case, I can do max X or I can do min X. If I do min X, it's AA Garcia. Oh yeah. Max X. So as you can see, that doesn't change, but if I change this value to, I think 2, then we get Adriana Garcia versus, so again, AAA Garcia is the first one, Adriana Garcia is the second one. So it handles the duplicates pretty much flawlessly in this case, because they're just going to stack up, but they're all going to have unique IDs because, one of the nifty things about doing things this way, where you concatenate things up into a path and then grab them out, is you don't run into the problems with like rank X where you have it gives you back a bunch of one 3 1s or 4 2s and all of that kind of thing. Every row in this table has a unique key or index, if you will. So the value this value column, which is generated by generate series. So there you have it. Again, a scenario where, again, index becomes useless and superfluous, if you will, and you really don't need it. You just want to learn one way of doing it, and it works for all situations. Okay, on to offset. All right, so here we have, so what I decided to do here is, I don't know why I tried this, but I was like, all right, so, in this example, we have, um, we're summing up our column here. We're just using a default aggregation. We're using the sum of column 2. So this thing is aggregated, right? And then we go through and do our offsets, and the only one that worked was offset 4. So I was like, well, what if you don't summarize? And can it handle, if you remember from the data model, I had duplicate pickle rows. I had a pickle row with a value of 1 and a pickle row with a value of 10. I was like, just kind of interesting, similar kind of concept, right? What happens when there's duplicate values? And I kind of expected similar behavior with offset as index, but it even got more bizarre, if that's even a thing. Um, so if I add offset 1, these are wrong. And this is not a single table data model. Like we had, this looks very reminiscent of our single table data model. And as you can see from here, this is from table 2, and this is from table 1 or table. And so it's a star schema. We're using a star schema, but we just haven't aggregated our rows. And so we get some bizarre results. That's all I'll say about that. And it kind of messes up our non-summarization, if you will. But even like we even start getting bizarre things like column 2, is 40, and this is 33 and 12, and it's like, okay, where did it get that from? How did it mess up just column 2 not being summarized, right? Like it just totally changed. Pickle's not 40. Where did it get that? If we do like offset 2, it's just we just don't get anything, right? It's just blank. Um, and these are the same formulas we had before. It's just completely blank. What happens if we do offset 3? So it preserves our 1 and our 10 for pickle, and this is probably mostly correct. Of course, this is the one using where we get rid of calculate and use sum x, but it's sort of correct, except that pickle, it sort of makes sense that maybe you'd have 40 for pickle and another 40 for pickle. Although what we really want, right, is we want to have like 40 for this one and 1 for this one, because we want this pickle, the previous offset is should be pickle. I mean, in theory, right? If we're not summarizing and we just want the rows, right? In terms of the offset, but anyway, not exactly what you're expecting. Closer, maybe. It does preserve like the 40 for orange, and it gets the 12 for the lime and the 33 for the orange, right? Right. So those that's kind of right, and then this 40 is kind of right, and this 40 though is not what we really want. We want it to be 1, or at least that was the concept of this exercise. So this one's maybe sort of kind of right. You could make a case for it. All we have to do is once again get rid of calculate. All right, so let's do this. Let's do offset 4. It's blank. It's just this is the one that actually worked, quote unquote, in the last scenario, although not in single table data models. It doesn't work here either. So if you're not summarizing it, it's just gone. Okay, so what happens if we do offset 5? It's blank. Offset 6, it's blank. All right, so none of these are really what we really want. But what if we use offset no offset? Do we get anything better? Okay, so this function's actually very similar to to our offset 3, although we do get an extra value here, the 100, which should be correct, right? That's our kiwi getting the previous value of banana. So it's more correct. It's then offset 3. And, we still have this problem with 40 and 40. But we can correct that. And as you can see right here, this offset no offset 1 gives us 112, 33, 40, and 1, which is what we would expect. As far as, that was the purpose of this exercise, was to have duplicate values and all of that. All right, so how do we achieve that, right? We just made a very slight modification to the offset no offset. So the original formula is this, right? So we have our distinct, where we grab from our column 1, we concatenate that up. We add our columns, where we use generate series, and we grab out the path item, we sum x or value, right? So it's a little different in this case. What we have to do is we select our columns, we do an all selected of our table for column 2. So we have a column 1 and we have a column 2. And then we're not doing distinct in the column 1 case, because we have duplicate values for pickle. And then what we do is we concatenate x, both of those. We create 2 different table texts or paths, one for column 1 and one for column 2, sorted the exact same way. We have the exact same number of values, sorted the same way. So then what we can do in our add columns, we can generate the series. We can just pluck the path items out from table text, and then table text 2, the same items, and then away we go. So we do a little fancy magic with our offset to make sure that we're grabbing out the right value and everything like that. So we're doing product equals max of table column 1, and the value equals the max of table column 2. And then, there we have it. It's pretty simple. Yeah, that's it. And we grab our index value. So easy peasy, if you will. And these are correct because it's in context. We're just grabbing out what column 1 is, and we're grabbing out what column 2 is in context. So return the right things, and we get the expected answer. Let's put it that way, other than our total, which we know how to fix. Not that I'm going to belabor that point in this video, but if you want to vote for that idea, it's out there in the ideas forum to fix measure totals, or make them easier, provide options to make it easier to just sum the rows, and then we could fix that really easily. So I don't know. So this video, I mean, again, I'm just kind of demonstrating just how easy, how when you throw around terms like easy. None of this is with offset seems easy to me. It seems like offset really in index and that sort of thing. It's like all the stars have to align for them to even work at all. And this is kind of the problem with these black box functions that Microsoft comes out with, like the time intelligence functions and calculate and things like that, is that there are all these black box functions with all of these numerous internal rules, and it's really easy to get bad results and blanks and weird things happening, and you really have no control over it, because it's all just however they coded it internally, and you have no insights into it at all. And it'll just come back and say, oh, there's an error and in that situation, and I'm now useless, so sorry about your luck. None of that to me says easy. So I think Microsoft, and Brian Julius, I've heard him state this a few times, where it's like, every time Microsoft tries to make things easier for the end users, they end up making it worse for everyone. He uses examples like auto recognizing relationships, and all that. Auto exist is another one. It's like, can we just turn that off? Give us an option to turn it off. At least we have an option to turn off like relationships, and and the auto time intelligence stuff and all of that stuff. Just they're all there. I think that Microsoft thinks they're making it easier, but all they do is make it worse. And I can't argue with Brian on that point, because it seems like the same way to me. Only for me, it's all the DAX functions that they do. It's like, well, we'll make time intelligence easy. No, you just made it super complicated and useless, and just people just learned the better way of doing it. And Brian would advocate offsets, and all of those calculations are fairly easy to accomplish year over year, all of that stuff. without using the time intelligence functions. It makes a ton more sense. And it just works better in more situations, in my opinion. So that's it for this video. Hope you enjoyed it. I don't mean to bag on these new functions, but I mean, maybe they're building blocks for something bigger and better, but if the building blocks are bad, then whatever's built on top of them is also going to be bad, in my opinion. Maybe I'm wrong, but that's my fear. So hope you enjoyed this video, and I'll talk to you next time.